For my money, one of the greatest games ever made is Every Extend. In this game, you control this little orange bomb, and as the obstacles get closer, you press a key to explode. Notice that as you spawn in, you can control where your character is. Once he explodes, you can no longer move around, and there's a little delay while you wait for your next bomb to spawn in. So one way we can think about that is with a state machine. So we could say at the beginning of play, we're in this spawning state, and when that animation is complete, we start being able to move around. We press the explode key, and that makes us explode, and after a brief delay while we're waiting, then we go back to spawning again. We continue that as long as there's lives. In the state machine, I've indicated what the transitions are, so we know when to go from one state to another. It's pretty clear that we could model this with a large set of Boolean variables, but we wouldn't want to. What we really want to do as software developers is represent these states more explicitly. So in this video, I want to show you how to use enumerated types to do that within Unreal Engine 4. I decided to start again with a completely blank project, and I want to show every step required to build this so that you can follow along if you want to. All I've done is connect this to a Perforce depot, and I've done that because some of my students have been struggling a little with Perforce, and I thought it might be helpful just to show a normal workflow as part of getting something else done. So the first thing I want to do is make a new game mode so that I can make a new pawn. So I'll just do that all in blueprints here. I'll make a new game mode. We'll call it BP game mode. And we'll make a new class. This will be our pawn called BP player. And in the game mode, we can say that our player is BP player. That's good. And then in our project settings, under maps and modes, we want to make sure we set our new game mode. And while I'm here, let me set up my input mappings as well. Alright, that should be good for our project settings. Let's go ahead and do something with this player. To keep life simple, I'm just going to use some of the built-in primitives. So let's grab a sphere, and that's fine for our purposes. And I'm going to also use a movement component. Here we are. I have another video about that, and I'll add a link here so that you can watch the video entirely about how to use this floating pawn movement component. For now, all I want to do is make sure these settings look okay. Yeah, that should be fine. What I want to be able to do again is spawn this in and make it explode, so I think it's going to be helpful to have a custom dynamic material to do that. So let me do that right now. We'll call this mPlayer for the player material. And what I'd like to do is as it explodes, I want to change the opacity. So I'm going to change the blend mode to translucent, but I still want lighting to work. So I have to go down here to the translucency section and set this to, I believe it's forward shading. We'll try that. If that doesn't work, we'll try a different one. Yeah, okay. So for our base color, we'll just use a constant color here. And let me get maybe a nice blue-gray, something like that. Good, slightly purple, that's okay. And opacity, I want to make that into a parameter because I want to be able to scale that from 0 to 1. And by default, the opacity should be 1, and we'll go ahead and set the slider min and max as well. That actually took a really long time, so I'll edit it out of the video. Don't panic if it takes a while. So we know when we're using dynamic materials, the way that we want to instantiate those is in the event graph. So on begin play, we can create a dynamic material instance. And this will be made from mMaterial. I don't think I'll need either of those, so clean them up. That looks okay, and let's also, let's see, I believe that will set it also. We'll check that. We also want to promote this to a variable so we can keep a handle on it, and we'll call that the dynamic material. That'll allow us later on to fiddle with that opacity parameter. Okay, so back in the level, I'm going to drop on a camera. And let's just make this look down and pull it up here somewhere. Just look down at the world. Alright, we'll try that out. And we'll try, let's see, this is with the camera selected. Yep. We can make sure it will automatically be used. Set that to player 0. Great. So if I play this game, there, we're looking down at our spawned actor here. If I use WASD, he doesn't yet move around at all, but we'll fix that right now. In fact, I think I'm going to pull that camera out a little bit. There, that's fine. Make sure we give this a name when we save it. We'll call it default map. And while I'm thinking about it, I'll go into my project settings and set that as the editor default as well. So we use default map there, default map there. Good. Shouldn't be any surprises if we have to close and reopen. Okay. Our next step will be to get the movement working. So I'll use a technique I again showed in that previous video. We will listen for the move up event. And when we get that, we can call, is it add movement input? Yeah. Oops. On this pawn. And this will tell us the value, and the direction will be the forward vector of the sphere. That looks good. Move right will be the movement input. With that value, the right vector. Okay, so let's just try that out, see how it looks. Good. I can move this guy around. Whoops. Oh, I think I forgot a minus sign because left and right are both moving. I'm right. So let's check the project settings and input. Yep, not the first time I've made that mistake. All right, good. Okay, and again, just to show some process, that's a point where I could just submit all these changes to source control and say that we've just created a simple moving sphere pawn. All right. So there's no spawning or exploding or anything, and I think where I want to start is with the spawning idea. So again, let's look at that state machine. That's the first state we want to be in. So let's see how we can handle that. First, I'm going to make an enumerated type to represent these 4 different states, and I can do that directly in Blueprints. Notice that if you want to be able to access the enumerated values in C++, you're much, much better off creating the enumerated type in C++. But if you can understand how it's working in Blueprints, then you can definitely do it in C++ instead if you want to. So this is just simpler for the video's purpose. We'll call this ePlayerState. And in here we can give it a description like a state the player bomb can be in, and we'll give it 4 values. In fact, we'll just do that. First value will be spawning, next value will be moving, next value will be exploding, and next value will be waiting. Good, and save that. Now, in my player class, I want to have a reference to what my current state is. So I'll add a new variable, and I'll call this my state, and its type will be ePlayerState. Good. So compile and save that. Then I can set my initial state to be whatever I want, and yeah, spawning is reasonable. In order to do the spawning, what I'd like to do is make a new custom event called spawn, and I'll call that here. The main reason I'm doing that is because I know from my state analysis that I'm going to have to spawn again, so it's going to be convenient to have that in a custom event. Okay, so what do I want to do when I spawn? I think what I'll do is create a timeline. We'll call this spawn animation, Do a nice quick and dirty timeline-based animation. I want this to play from the start every time. And let's see, we'll take the scale, add a key at 0, 0. So at 0 time, it'll have 0 scale. And then we'll add another key at half a second in, we'll be at a scale of 1. Here, we'll zoom that in. And that's actually the whole thing. I'm going to do this whole spawning in half a second. And conveniently, I can use the same interpolation for the scale and also for the opacity. So I'm going to call this scale and opacity. If I select these key points, I can make them auto and do something like, here, let's do this. See how that looks. Alright, so there's our timeline. So as this runs, every tick we want to update the scale of the sphere. So I can say set scale, world scale 3D on update. And if we split that struct, we can just send that in for x, y, and z. Then we grab its dynamic material, and we can tell it to set parameter. This is a scalar parameter. We called it opacity. And that will again be the same value. And just a double click to make a control point. There. Okay. And when this is done, we want to change the state from spawning to moving. And again, that's by definition of my state analysis. All right, let's try that out and see what we have. That was pretty neat. Now, of course, if I move around and I press space, nothing crazy happens. But notice that as it's spawning, I can move it. A little tricky to see as this comes up, but it's movable within that spawning state. Good. So that looks good so far. Now let's make it so that when I press the space bar, it explodes. So we can say this will be on the input event explode. First thing I'll do is change the state from, well, actually no, that's not right. Here's the first place I have to ask the question, am I in the moving state? Here. We can't go directly from spawning to exploding. We have to be moving first. So let's see how we can do that with our enumerated values. We can take the current state of the system and we can switch. And notice Blueprint makes this really convenient for us because it maps in 4 different output execution pins for each of the different states. Very nice. So if we're moving, that's the only one we care about, then change the state to exploding and actually play the explosion animation, which is going to be similar, just a timeline-driven animation here. So add another timeline. We'll call it explosion. And once again, I want to make sure I play it from the start each time. So we'll go into the explosion, and we can, let's see. Let's take the scale again from 1 up to 5 over half a second. Oh, sorry, this should be at time 0. No, yeah. At time 0.5, go up to 5. At time 0, be at 1. All right, so we're going to go from 1 to 5 over the space of half a second. And once again, we can do some nice interpolation here. We want to arc that in. Oops, do a similar thing here. There we are. Arc that in. That'll be nice. What's the other thing to control for then? Well, we'll rename this to scale. Let's also run the opacity. So we'll add another track here, which will go from 1 at time 0. Oops, got that backwards. At time 0, be 1. And at time 0.5, be 0. Right, so as it explodes, it's going to become less opaque. I'll just select that with a shift click, and right click and say auto, and then if I wanted to I could change the smoothing function there. Alright, that looks okay. Let's try it out. Here's the explosion timeline. What we need to do again is set the scale of the sphere. Every update. Here, split that struct so we can run the scale in. And then grab the material. And we can say set parameter, opacity, and that will be this value. All right, let's take a quick look at that. Spawned in, press spacebar, it explodes. And of course it doesn't come back. There, and notice I tried pressing spacebar as it was coming up, it didn't come through. That works okay. Good. So, after we explode, we're going to set ourselves into this waiting state. And that will just be, let's check my state analysis. After 1 second elapses, we go back to spawn. So we'll just delay here for 1 second. And when it's done, call spawn. That seems okay. Let's take a look. Explode, wait a second, comes back. Now it's coming back where we died, and in fact I can still move as it explodes. So let's handle those one thing at a time. First I want to make sure so that I can only move when I'm in the spawning or the moving state. So we'll just do the same kind of trick here. We'll take the state and we'll say switch. Now again, these macros are really convenient here because we can say both of these states allow moving, but the other ones will do nothing. They'll just ignore this input axis. And then the same trick over here. We'll take the state and the switch. Say spawning or moving. That looks good. So if I explode, I can no longer move. Good. What was the next step? We'll go down to here and say, so we can only explode from there. That's good. We'll call spawn. Where'd that go? Here it is. So when I spawn, before I play that animation, let's just move the actor to the player start. So we can say get all actors of class, player start. And remember, I'm just using the player start that was in the default empty blueprints project. I expect there to be only one, so I'll just get the first one out of there. And I can get its transform, actor transform. And I can take my default scene root and I can set its transform. Set actor transform. Whoops. It got a little bit ugly. Let's see. Here we are. Set actor transform of self to that spawn location. Now remember, at this point my material has no opacity, so the player can't see a thing, right? Then play the spawn animation. Alright, let's try that. Neat. Oops, should wait for him to respawn, right? Explode, comes back in the middle. Nice. Not too shabby. Alright, so let's double check our state machine. We go from spawning to moving after the spawn animation completes. We go from moving to exploding when we press the explode key. After the explosion, we wait, and then 1 second elapses, we come back there. I think we got it. There was one subtle mistake here, which is that after we explode, we go into waiting state, we delay, and then we spawn. But in fact, we never go back into the spawning state. That was an oversight from over here. What I'll do is, I'll make sure we set the state. As soon as we get the instructions to spawn, we'll set that to spawning. What that means is that will allow us again to be able to move while we're coming in, like that. And that's how it's really done. Now, of course, more complicated state analysis involves us looking at this and saying, well, while we're moving, if we bump into an obstacle, maybe we take some damage, or maybe after exploding, we check to see if we have more lives remaining. But if you can do the simple analysis and use enumerated values, of course, you can do a more complex analysis. So my last step, of course, should be a Control-Shift-S, make sure everything's saved, and then push it to source control. All right, I hope you found that useful. Have a lot of fun doing state-based analysis in Unreal Engine.